For today's topic, we're going to be talking about numerical and written expressions. You'll be able to create a numerical expression from given written expressions. You'll know when you have it, when you can create a numerical expression that correctly demonstrates the written expression. Some important vocabulary to have is one, knowing what a numerical expression is, knowing that it is a mathematical statement that involves only numbers along with one or more operation symbols. And then a written expression is a sentence with a minimum of 2 numbers or variables and at least one math operation. Other important vocabulary to have is to know are signal words within a written expression that show you what operation it is talking about. So when I hear the words plus, sum, total, more than, increase by, I know that I'm talking about addition. When I hear minus, difference, decreased by, fewer than, less than, I know I'm talking about subtraction. Times, product, by, or when we say we double or triple something, we are talking about multiplication. And then when we divide, we talk about the quotient goes into, half of, a third of, we're talking about division. Knowing these important words is going to tell us what operation we need to be putting into our numerical expression. So, when we talk about this, essentially we're given a written expression, a set of words that tells us what to do, what kind of math we need to do. For example, if somebody wants me to find the sum of 4 and 6 multiplied by 5, when I hear those words in my head, I need to be able to see this numerical expression. I know I'm adding 4 and 6, and then I'm multiplying it by 5. Another example, 8 less than the quotient of 60 and 3. When I see this word quotient, I know that I'm going to divide. When I see less than, I know I'm going to subtract. So it's up to me to put this in order. 8 less than the quotient. So first I need to find the quotient of 60 and 3. So I would do that by dividing 60 by 3. And then subtracting 8 from the answer to that problem. Last example, the product of 12 and 3 divided by the difference of 11 and 2. When I see product, I know I'm going to multiply. When I see difference, I know I'm going to subtract. And when it tells me that I'm going to do this with these two numbers, I want to do that first. Then I'm going to perform this operation, 11 minus 2. And right here in the middle, it tells me that this will be divided by this. So I need to find the answers to this, and then divide them. So, for example, I have subtract 18 from the product of 6 and 8. It's telling me that I want to subtract 18 from the product, so from the answer of multiplying 6 and 8. So I'm going to multiply 6 and 8 first, and then I will subtract 18 from it. This is the numerical expression that represents this written expression. Inversely, I can do the opposite. Sometimes I am given a numerical expression and I have to create a written expression from it. So I have to think in my head, if I was going to say this out loud, how would I describe this problem? What would I tell people to do if they couldn't see this numerical expression? So I could say 6 more than the difference of 50 and 10. And I would write that out, 6 more then the difference of 50 and 10. This tells whoever is trying to perform this operation that I need to find the difference first and then add 6 to it. Again, here is a great anchor chart if you need to have an example handy. I would print this out, glue it into your math notebook, or have it handy around your desk. Go ahead and continue on for some extra practice on this topic.